This is a help video for the unit test part 2 modeling with geometry. You want to answer the questions below. When you're finished, submit this test for full credit. It's worth 10 points. A box without a top is to be made from a rectangular piece of cardboard with dimensions, sorry about that, 8.5 inches by 11 inches by cutting out square corners with the side length X and folding up the sides. If you want to see a visual of this, on your document, I put an example of a help video that you can watch this done and modeled for you. So you're going to take a piece of paper or card box from this paper. It's 8.5 by 11. You're going to cut out these corners. The length is X, and you're going to cut them out. And this is going to be folded up to make a box with an open top. So again, 8.5 by 11, and you're going to cut out an X. So this length right here is going to be 8.5 minus an X minus another X. So 8.5 minus 2X. The length of this right here is going to be 11 minus this X and minus this X. So the length is 11 minus 2X. So you're going to write an equation for the volume of the box in terms of X. Part B. You're going to use Desmos to estimate the value of X to the nearest tenth that gives the greatest volume. So you're going to, what value of this X in this picture, what is the number, what is the amount, what is the number that is the X that will give you the greatest volume of your box? So in order to find that, you're going to graph it. So first you're going to write your name in the first box, line 1. You're going to then plug in your equation from part A. Mine's plugged in here. I said it was 8.5 minus 2X, 11 minus 2X, and its length times width times height is the volume of a cube or a box. You're going to click on the highest point of the curve. So you're going to get a curve and it's going to go up and down, but you're going to click on this point right here that's going to look somewhere around 1.5, somewhere around 1.5, somewhere around that number. So my value of X, if my X is 1.585, my volume is at a maximum of 66.148. So you're going to place a snip of your work on this document. Please don't turn in another document or a PDF. Make sure you snip it and put it on this document, just so you just turn in one document. You're going to explain your process. What does the value of X represent? Hint. Look at the question above. What is it asking? So what does your X represent? You can pause here and work on that question if you're ready for number 2. I'm going to go over this one. A cube-shaped aquarium. I put a cube right here. The cube means all these sides are the same length. It has edges that are 3 feet long. So this is 3 feet, this is 3 feet. All these edges are 3 feet long. The aquarium is filled with water that has a density of 62 pounds per cubic foot. What is the volume of the water of the aquarium? Show all your work, no credit. Here's a video on how to find the volume of water in a cube. So you need to find the volume of the water in the cube. Next, you need to find the mass of the water in the aquarium. So this mass number right here, you have density, you were given density, and you found the volume in letter A. So you should be able to find the mass. Should the aquarium be placed on a table that can support a maximum weight of 200 pounds? Explain why or why not. Hint, use the mass you calculated. If you have questions about this, we do have multiple days that you can ask for help in class. So if you're working on this and you have trouble, please come into class and ask questions. We are here to help you.